Alright, hope everyone's doing well. So good time for questions. So I'll run through the ODP quickly, but any other questions on other stuff? Can you go over dialogue? Sure, what would you like to go over? So we talked about info boxes, message boxes, yes, no boxes. We talked about capturing output from it using the output FD switch, running it from a bash script. So is there something in particular? Yeah, we can do a quick run through it again. All right, let's start with the ODP. Let's dispense with that, and then we'll go back to dialogue, and we'll look at breaking things apart from dialogue and so on. So I don't even know what the last ODP was because they were in a weird ordering. It was 415, I believe. Yeah, so our calc program. So the main issues people seem to be running into was when you use a %C in scanf, that means a single character. And you can't use a string, you can't use an array of characters, you can't use a character pointer. It has to be just a plain old car. And since it's a car rather than an address, you have to put an ampersand in front of it. Okay, just like you do when you scan into an integer or a float. So that's one issue. When you have a character and you want to compare it to something like a plus sign, the plus sign goes in single quotes and you can use a double equal. Okay, characters are basically integers, so they work more or less like plain old integer numbers. But they're interpreted by printf, for example, as the ASCII code of a character. But they're really just small ints. They're 8-bit integers. So you can compare them with equal equal. You can't use string compare with them. String compare expects 2 pointers to memory, and it will look at what those things are pointing to and then compare character by character in memory until it finds a difference or it gets to the end of both strings. So this was my calculate code for this. Takes in a character array, right? So that's a string, that's the argument. It returns an int, temporary space for holding 2 numbers and holding the operator, and that's where you can see it's a plain old car. And then, as we talked about yesterday, just do your scan with %D, %C, %D. Okay, and all 3 of these are basically ints, so they get ampersands in front. And then check the return status. If the status is not equal to 3, you know that it didn't parse with that pattern, and so the instructions say return a -1. Alright, so that says, improperly formed expression. Otherwise, we know that these 3 things all got scanned. We have 2 integers and we have some kind of operator in this character. And so you can do this with a bunch of ifs or if-elses, or you can use a switch. So I use a switch on the operator. If it's a plus, then I'll add my 2 numbers together and return that. If it's a minus, subtract, and so on. And if it doesn't match any of these, then it uses the default option, and in that case, return -2. And normally when you do switches, you see the word break after this. Break says break out of the switch statement. Without that, it flows from one statement to the next to the next. So normally if I matched a plus sign, it would do this, and then this, and then this, and so on. So if you wanted to kick out all the way to the end of the switch statement, you put a break in there. I don't need a break here because I'm doing a return. And if you say return, then it's not going to, be able to flow through to the next parts of the switch. So, millions of ways to code that, but that's the effect of one solution to that ODP. And I actually posted ODP grades already because I tend to forget about them and they go for a week before they get posted. So I posted them up before class this morning, so those should all be in there now. All right, any questions on the ODP? And we're done with ODPs for the week. Had more people come into office hours last night. That was really good. Got through some good work with people. Got through some debugging sessions with people, and that's been productive. Registration started this week, so I'm starting to get more people coming in for advising during office hours. So the contention for that time is probably going to increase for the next few weeks. So that's just a heads up. If you're going to try to find me in office hours, plan on coming in early, I would say. All right, and I sent an announcement related to group work for homework 7. I just sent this out this morning. So I've heard from very few people saying that they want to work in groups or that they want to be placed in a group. So the deadline is tomorrow at noon. Okay, if you want to work in a group with people, send me email on the Linux server. Tell me the full names of all the people in your group. Okay, and I'll make note of that, and that's the end of my involvement in it. If you want to work in a group but you don't know who to work with and you want me to try to put you in a group, send me email to my regular email account at clark.edu. And you got to give me your email address in there and tell me that it's okay to share that with people that I match you up with. Okay, and whoever I've got emails from in that category by Friday at noon, I'll try to break it into groups of at least 2 people per group, and I'll send an email to all the people in there with all of your email addresses. Okay, but I can't do that unless you send me a note and say, go ahead and share this with whoever you're putting me in a group with. All right, so even if I've already heard from you saying you want to be placed in a group, send me an email again, send it to my clark.edu address, put that information in. And then if I don't hear from you by Friday at noon, I'll just assume you're working alone, and that's an option. All right, so let's talk about the dialog command. So right, most straightforward dialog, probably a message box or a yes/no box. Most of these things take a title and then a height and a width, right? So dialog, message box, info just creates an info box and lets you read it and then say okay and go on. Those are pretty straightforward. The yes/no boxes, right, let you choose your answer to some question, and you can figure out which button the person clicked by looking at the return status from bash. So if they selected no, you'll get back a 1. If they select yes, you'll get back a 0. And you can also add an extra button. I don't know if you can add an extra one on the yes/no. Yeah, you can. So if you choose the extra button, then your status comes back as a 3. Yeah, so someone's saying that's counterintuitive. Yeah, it kind of is, except we think of 1 as true and 0 as false. But for a lot of operating systems, the default return value from successful commands is 0, and the non-zero indicates an error. The reason being that there's multiple error conditions, and you can look at something called error no and see a list of all of these things, and 0 feels more special than 1, I guess. So 0 is the usual way we indicate success, which is what an OK button is doing. And then if you do something unusual, you get a non-zero result. So it's just another thing to keep straight. There's lots of those. All right, so we've got basic boxes where you can display information. You can get button choices from the user, up to 3 buttons like this. And remember, you can specify the height and width yourself if you prefer. All right, and then there's also these options where you can get information from the user. So for example, an input box. So let's say input box. So you can display a title and leave the person with an area to type. Right, and the output of this command is sent to standard out. So in this case, it just displayed wherever my cursor happened to be, but usually we want to catch that, so we'll throw the whole command inside back quotes, and we'll add an extra switch, output FD. Output FD1. And then if we look at that answer, we've got whatever the person typed. Let's see. How do you store information into a file? There's a few ways, so I think you could probably do this. And then if you look at new file, it'll have that. But you more often capture the output of commands into shell variables. And then if you want to put that into a file, you could just, you could echo your answer, but put that into a file like that. Yeah, let's make an appointment for world peace. That sounds good. Is there a way to not have the output sent to standard out? Like just save the output without having it show up on the screen. Yeah, so that's what happened just now when we captured. Right, so if you do that, it's not going to echo it to your screen. It's just going to save it in that file. Same thing if you do a calendar dialog or something like that. So that's exactly what you're doing, is you're saying send the output to standard out, and then the back quotes capture standard out, and this assignment throws the result of that into a shell variable. And if you want to be super stealthy, right, you can do a password box. And so now you can type whatever, and it all goes into there. And that's the way you're supposed to do secure passwords, by the way, not showing an asterisk for each character so that somebody watching knows exactly how long your password is. Does anybody know why we print asterisks when people type in passwords? what the origin of that is. So I don't know this definitively. I've never researched it, but it seems plausible to me. So you know, back in the 70s, there weren't a whole lot of CRTs around. Everything was done with printers, right? So either typewriters like old IBM Selectrics or deck writers that had a moving head that went back and forth. But what you would type would get printed on paper, right? And that was used instead of a screen. And so there was a problem when you were typing a password is your password would be printed on a piece of paper, and now you had a piece of paper with your username and password, and you'd have to, you know, shred that or burn it or swallow it or something like that. So in these old days, when you would get to a place where it wanted you to enter a password, it would first print out, you know, something like a series of M's, and then it would backspace 8 times, and it would print out a series of X's. And then it would backspace and it would print a series of W's. And it would do this, you know, 3 or 4 times and basically make a blob, and then it would go back. And then you could type your password, and it would be harder to see because, you know, it would be mixed in with all these big blobs. And I think when people started using CRTs, right, they just kind of mimicked that behavior and said, yeah, let's, you know, print out asterisks there. But, you know, with the downside that, as I said, somebody looking at it knows that your password is exactly, you know, 9 characters long. You just made their search a whole lot easier if they're trying to guess your password. So Unix generally, you know, like when you set your password, it doesn't give you any feedback as you're typing it in. Same idea. So that's what you're seeing with your password box. It's totally silent, but it can be disconcerting because it looks like it's not working. All right. So what else with dialogues? Yeah. So this is the main thing to take note of is this output FD1 that takes the output from the command itself, right? Not the output that makes the window, but the output from the command and sends that to standard out. Can you change the font type and size? That's a good question. I don't actually know. I would say do some research on that, either in the man page or look online. So these man pages, these are just coming through the more or the less command. And inside more, you have all these things you can do, including a slash to search for something. So I can search for font, and maybe find something useful. Nope, so it ignores fixed font. And I can hit an N to look for the next one. That's all I found for font. I know you can play with the color. But I'm going to guess they don't let you play around a lot with the size or the font. Because what this is doing is this is sending a bunch of special characters to your terminal session, and those characters are interpreted by PuTTY or, you know, my terminal program I'm running or whatever, to display, you know, shapes with different colors or things that look like corners or T-junctions or things like that. It's a bunch of old things called VT100 codes. VT100 was one of the first generally used CRTs in computers, and the VT100 interpreted escape sequences. Anything that started with an escape left bracket would have special meaning. It would interpret those to display funny characters and so on. Those are still used today, okay? All the stuff that's coming out here, this is part of VT100 sequences. So if I take the dialog command and I don't put that output switch on it and I just redirect the output to a file called haha, you can see all of the escape sequences that are being generated by the dialog command. Escape bracket question mark 1049H. escape bracket 1 semicolon 22 R escape. So that control left bracket is an escape character, ASCII 27. And these cues are forming a line going across the screen if you've put the terminal program into a mode where it interprets those as VT100's graphics commands. And somewhere up here there's some command to the terminal to go ahead and interpret those accordingly. And this is just magic, you know. So you can play with that. And a lot of these are cursor positioning commands, so like row, semicolon, column, row, semicolon, column, and so on and so forth. When you hit an arrow key, that's also sending VT100 escape codes. So, right, if I hit the down arrow key while I'm in insert mode, what I get is a bunch of B's. When I hit the up arrow, I get a bunch of A's. When I hit left, I get D's. When I hit right, I get C's. Right, but the up arrow is sending typically an escape bracket A, escape bracket B, escape bracket C or D, and that's how your keyboard sends an instruction to move up, down, left, or right. And it's up to the shell, the program you're running, to interpret those as cursor movement commands. But it's really just sending escape codes. And you can look those up on websites and see what the whole list of them are. And it's an easy way to do pseudo graphics. That's how you play Rogue also. And if you get your terminal messed up while you're playing with dialogues, like right now, you know, I'm not getting my new lines out, just type the command reset, and that'll usually get you back to where you want to be. And so if you play Rogue, oh man, I can't play Rogue. Right, so Rogue is another one of these things that just uses escape sequences and makes it look like you've got graphics. Yeah, I found a potion of clairvoyance. That's cool. And if you want to get better at VI, I recommend playing Rogue because you use HJKL to move around, which is the way you move around in VI. And you have to beat the high scores that my students left last year. Always summoned a monster. All right. Yeah, NetHack, same idea. All right, so for the dialog calendar, is there a way to set the default year? Yeah, there should be. So, although if you're getting a default of 1981, I'm guessing that's what your computer thinks the year is, maybe. NetHack's still being developed. That's cool. I didn't realize that. So you can say, I gotta get my echo back. Okay, need a title. All right, so it should default to whatever your computer thinks today is, but you can also specify a year, month, and day, and so we can do, 15th September 2000, and so it'll default to that date, and then you can move around as usual. So yeah, 3 optional arguments at the end: day, month, and year. Let's see. Yeah, exactly like bash color codes, escape codes. All right. And one more time. Right, so you can capture your output by putting it, the whole command in back quotes, add the output FD1. If you don't have that output FD1, then the whole dialog itself goes into your variable. And if you look at what that variable actually looks like, it's all of your escape codes. So specify the output file descriptor. Made a bash command to keep track of election returns from Georgia and also from Pennsylvania. So we'll play with this later, but there's a command in Linux called curl, and curl basically lets you go to a web page and request the contents of that page. And so I just found a page with Georgia election results from the New York Times, and I passed that to the curl command, but I put it in back quotes, and then I run it through some stuff to pull out the particular information that I wanted for candidates, and then just change it into a bunch of separate lines by using sed, which we're also going to talk about. Sed is a way to edit a line or a file of lines based on what we call regular expressions, which is also something we're going to talk about. And this is just plain old Ubuntu. I think it's 18.04. Actually, it's Xubuntu because I put XFCE on top. And then, I made a general version one that instead of being Georgia or Pennsylvania, you can just put in $1 and it'll pop in whatever command line argument you have and get the results for that. So I can say gen Washington and see our home state results. So not that I spent all night looking at numbers and making predictions or anything, but just for the sake of education, I thought I would play with curl. And yes, sed is the stream editor. Perfect. All right. So let's dig around a little with some of these commands. Yeah, we are waiting on Nevada, although I'm going with the predictions for that one. Actually, they were talking about announcing something at 1 Eastern time. Let's see. Still 12,000. All right. Let's talk about awk a little more. So we touched on this yesterday. And awk is a whole programming environment that we'll dig into. But let me review a little more calmly. One of the main uses of awk, which is for splitting up fields, and this is something that might be useful to you in homework 7, awk, and then we supply what's called a program. It usually goes inside single quotes because it has lots of special characters that we don't want interpreted. And you put your program inside curly brackets, and you can basically say things like print $1, comma, $3. And this would say, on each line of my file, print the first and third entries. where first and third fields, where the fields are separated by spaces. And if you're not separating by spaces, you can say dash uppercase F and then specify what the field separator is. So let me just give you a quick example or two of that. You can do that, but you don't have to. Here's some information I have from a grading file from past ODPs. I've modified the names accordingly. But this is a file with a lot of information in it, but the information is always the same. There's an ODP, a name, a date range, a number of points awarded, and the maximum number of points that can be awarded. And unfortunately, I separated this with colons, and the timestamp itself also has colons inside it. So that's a little weird. But if I wanted to just get a list of ODPs and names just to see who has done their ODPs, it's really straightforward with awk. So I'm going to do awk-f colon, saying separate by a colon, and then I can say print $1, comma $2, not parent. Oh, and I have to give it the name of the file. All right, and it prints out a list of field 1, field 2. The comma that I used said separate these things by spaces. If I wanted something different, I could say, let's put a pipe in the middle of them, for example. And so there's a pipe. But it's that straightforward, right? It's really just a way to break up a field into whatever pieces. And if I wanted to add the name, so let's see, 1, 2, 3, 4, 5. Looks like fields 6 and 7 give me the grades. Alright, so there I can see, the score that people got on each of these. And this is something that, may seem kind of like useless at first, but when you have the ability to process files like this, at some point you're going to start seeing a lot of ways to use this. So in your calendar program, for example, you may have, calendar stored by date and time, and then, a description of the appointment. And you might decide to put other information on that. You might want to indicate an importance of the appointment, or a starting time and a duration, or a list of people who are invited to whatever the meeting is, and so on. And the easiest way to store that in a flat file is just as a bunch of columns, and separate it by probably not spaces, because your description is probably going to have spaces in it, but some character that won't normally appear, like a pipe or a tilde or something like that. And then if you want to pull that field apart, you can use something like awk. And if you have a shell variable that has a bunch of information on it separated by spaces, you can throw that into awk also, right? So I can say echo $x, I can pipe that into awk and show me the first, second, sixth, and seventh fields. But I gotta specify the separator. Right? And maybe I want some commas in there to put spaces in between them. And so if you're running a dialog and you get information back from the user and you want to break that into fields, right? Or if you're using a checkbox or a menu dialog or something that gives you space separated information, you can break that apart using awk. And if I wanted to pull this into further individual pieces, I could say something like, ODP equals back quote. Right? And user equals this. And points equals that. And max points equals that. So now I have a shell variable called ODP that shows me the name of the ODP. I have a shell variable called user that shows me the username. I have a variable that tells me how many points they have. I have a variable that tells me the max number of points. And if I want to compute their score from 0 to 100, right, I can do a little arithmetic. Right? And think about what's going on in here, right? We got a variable x that came, from I don't know, searching in a file or something like that. I cheated. I just grabbed the first line of this file. But we have a variable x that looks like this. And let's go ahead and run that through the awk. Let's echo it and feed that to standard in of awk. Let's separate on colons. Let's print the first field. And then I said, let's take all of that, and instead of displaying it, capture that output, take that output, set it equal to this, assign it to this variable ODP, or user or points or max points, and then go ahead and evaluate 100 times points over max points. Right? This is basically what your automated grading does. Hold on a second. Right, so this is how I process the grades file. The grades file looks just like that file we've been working with. When you do an assessment, a record gets written to the bottom of that file with the ODP or username, the timestamp, the grade, the max points. And this basically goes through and it ingests that file, grades.txt, and it uses a bunch of awk commands to break it up. There's where we calculate the score. So 100 times the 6th field divided by the 7th. And this is all, processing stuff that we'll talk about another time. But I basically get the name, ODP, and score. I save those, and I keep the last one using a hash. We'll talk about hashes later, too. And I use that to create an output file. And then that goes through another thing to turn it into a file that can be uploaded to Canvas. And it's just more, mostly relying on awk. And the stream editor said, which we'll talk about next, to just change this around into a format that that Canvas understands. And this is a little gnarly to try to read, but it's pretty easy to write. Right, so it's kind of like Perl that way. As you're writing it, it's very straightforward. If you go back later and you try to figure out what's going on, it's a little hard sometimes. But it's all just bash, right? Didn't write any C code or Java or anything else. It's just a bunch of bash statements. So I want to talk about more things we can do in bash that that let us do these kinds of manipulations. So awk, like I say, we'll come back and we'll talk about awk as its own subject, because awk is a whole programming environment, and you can do a lot of interesting things inside awk. You can use it like, an interpreted version of C almost. You don't have to compile it, but you can write a prime number generator in awk if you like. So we'll play with that. I also want to talk about sed. Sed is sort of the other counterpart to awk. And sed lets us make modifications to either a file or, a line. So here's my variable x. Suppose I wanted that colon to be a space, right? I could do something like this. Sed, quote, substitute a colon with a space. And if I feed in the line, this is fun, colon, I think, that colon gets changed to a space. So if I echo my string x and I pipe that into sed, my first colon here changed into a space instead. If I want to change all my colons to a space, I can put a G at the end and say, make this replacement globally across the entire line. And there you go, all my colons have changed into spaces. If I want to get rid of that field in the middle that had my timestamp in it and my date, I can do it with this cryptic looking statement. And I got an extra colon in there, so I could get rid of the trailing colon. And then I could take that and I could pipe it into sed and say change all my resulting colons into spaces, and now I've got, a nice cleaned up line like what I got with awk, right? All right, so we want to talk about sed, and we want to talk about regular expressions. And regular expressions tend to annoy people when they're trying to learn them. But the idea of a regular expression is basically like a wild card, okay, to a first order. Let's say that we want to search for something in a file, or we want to replace something in a file with something else, right? So typically we would say something like, replace a colon with, I don't know, maybe we want to replace it with a pipe. Or maybe we want to get rid of the colon, so we'll replace a colon with, just nothing. And there's a few places where we typically do this. We can do this inside VI. So if I VI this file, I can say, on this line colon, substitute a colon with pipe. And that first colon right there got replaced with a pipe. I could substitute /Nick with /me, and the word Nick gets changed with me. In VI, I can say from the beginning of the file to the end, substitute the string Nick with the string me, and it does that 5 places in the file. All right, so we can do simple replacements like this. We can do the same thing with sed. We can say substitute Nick with me and give it a file to read instead of reading from standard in, and everywhere that it found the word Nick, it would replace it with me once per line. We can also search for things in a file by saying grep. So grep basically takes a pattern that you're searching for and then a file to read from, or it'll read from standard in. So I could say grep for the word Nick in the file grades.txt, and there's the 5 lines where Nick appears. All right, so we have a few options. VI. We can say colon, substitute old, new. We can say sed, substitute old, new. We can say grep, search for some pattern in a file. But here's the thing, this thing that we're searching for in VI and sed and grep can be much more than just a pattern of characters. So if I go in here and I say VI grades, and I want to find a particular name, I can say slash, particular name. If I want to find a name with exactly 4 characters in it, I can say search for a colon, 4 dots, and a colon. Dot is a wildcard character. It says match any character. So this will show me every line of my file, anywhere that it finds 4 characters separated by colons. Right, so there's Nick, and there's data, and there's data, and there's John, and there's John again, and data, and so on. And these search patterns can get really sophisticated. Okay, and these things are called regular expressions. And you could probably do a whole course, you could definitely do a whole short course just on regular expressions. And regular expressions are quintessential, much easier to write than to read. But, like many things Linux, if this is the whole scope of regular expressions, this is how much we're going to actually work with. Okay? I'm going to go through, several types of things we can put in regular expressions. And by putting those small number of things together in particular ways, we're going to find a really rich way to search for things and replace things and modify files using regular expressions. All right, so we'll play around with that tomorrow. Send me those emails if you need to about groups, and I will see you next time. All right, thanks.